Yeah, my name is Frank Lurch. I'm the Managing Director of OpTecBB, the Photonics Competence Network and Innovation Network here in Berlin and in Brandenburg. First of all, I would like to welcome you back here in this afternoon session. And also, I would like to thank, before we start, to the organizers of this very nice conference here today. Especially, I would like to thank Nofar Sharon Reicher from AEAI in Israel, and of course Anastasia Janssen here at OpTecBB in Berlin. And of course, I would like to thank Shlomo Glaser at Photonics Israel for hosting the first two blocks of today's online conference. I would also like to thank all the speakers from the first two blocks and also all the speakers of this block. Already now, I would like to encourage everybody in the audience to use the opportunity to use the chat function and also the Q&A session after each of the presentations. Of course, it's still Corona time and we are still meeting virtually, and I think it's still a good platform to enable discussions via such webinars. All right, before we start, I would also like to share my screen real quick and welcome you for just one or two slides to give you a short overview of what photonics is like here in Berlin and Brandenburg, for those of you who are not familiar with the ecosystem. Well, first of all, we have a very long tradition also here in Berlin. Dates back already more than 200 years. Today we have more than 400 technology-oriented photonics and photonics-related companies, out of which around 300 of those companies are actually located in Berlin, and around 100 companies are located in the surrounding state of Brandenburg. And we also have a very rich R&D ecosystem. We do have 10 universities and universities of applied sciences, and also 26 non-university research organizations that are being active sometimes more, sometimes less in photonics. Some institutes are dedicated wholly to photonics, and in some institutes, of course, just a few people are working on photonics. The ecosystem in the industry, we have about 16,000 employees and approximately 2.8 billion of revenues. And the competences here in the region, they span actually from lighting technologies, so we'll hear about that today. They also cover laser technologies, laser material processing. It spans over to sensor technologies, the metrology and optical analytics. We also have a lot of applications and devices and technology being developed in biomedical optics, biophotonics in general, and ophthalmology. And we do have a long tradition actually here in Berlin on optical communication technologies. And nowadays, of course, there's a lot of talk on quantum technologies. So we also do see a lot of, especially research activities and startup activities in quantum technologies. And of course, OpTecBB is part of a larger German ecosystem of photonics regional networks. OpTecBB is part of the national network OpTecNet Germany. And I would like to use this opportunity to remind you, or to state a few save the dates. Shlomo Glaser was mentioning in the beginning of the session today. There's the Photonics Days Israel coming up in June. Will be held on the 7th to the 9th of June in a virtual manner. And I don't know if you have already heard, but the Laser World of Photonics Munich, the exhibition is now postponed to April of 22. And that makes, of course, such virtual formats, Photonics Israel, and maybe we here in Berlin at OpTecBB, even more important. And I would also like to point your attention already now to the Photonics Days Berlin-Brandenburg, which will be held at the beginning of October. And I would also like to mention our project, which is covering our internationalization activities, Phoenix 3, which is organized and being paid out of the program for internationalization from the Berlin Senate. Our partner here in Berlin is Berlin Partner, the regional development agency. So if you have any questions concerning locating or doing activities here in Berlin, or if you're looking for talent or technology, please contact either Berlin Partner or us at OpTecBB. And within that project, we are covering activities in Poland, Japan, and the US, and especially in Israel. And so I'm very happy that we can organize this conference here today. And with that, I'm already finished with my little introduction. So I stop my screen sharing, and I would like to invite Esther Elias from the embassy in Berlin, from the Israeli embassy, to give her presentation. She is the Consul for Economic Affairs and the head of Economic and Trade Mission to Berlin at the Embassy of Israel here in Germany. So, Esther Elias, the floor is yours for your welcome address.
Guten Morgen and shalom, everyone. Thank you very much for having me. It's a great pleasure to be part of today's online symposium on automotive and photonics and to speak in front of such an amazing audience. My name is Esther Elias, and I'm the Commercial Attaché, Head of the Israeli Economic and Trade Mission to Berlin. At the Economic and Trade Mission, we promote the bilateral economic relations between Israel and Germany. Our aim is to build long-lasting connections and deepen the economic ties between the two countries. We do this by organizing marketing campaigns and delegations, may they be physical or virtual, and representing Israeli innovations in exhibitions and trade fairs throughout the country. Today's great event is yet another example of all the changes our world has undergone due to the current global pandemic. Not being able to meet in person is a loss that is difficult to compensate, but having such a group of thriving people meeting in a virtual space is impressive. And as we all give our best to have a real exchange, we can make up for quite a number of the downsides of the situation. Most people are unaware of the great importance the field of photonics has for our daily life. The smartphone we use, the lenses in our glasses that make us see the world clearly, the cashier in the supermarket, the television program we change, none of it would be possible without photonics. In today's audience, we see great examples of highly innovative people and companies that always thrive for the next breakthrough and thereby enable exciting future applications. I'm so excited to take part in the upcoming discussions. Before I conclude, I would like to invite all of you and your companies to get in touch with us at the Israeli Economic and Trade Mission. We will be happy to assist you in any way with your endeavor to get in touch with Israeli innovation and pave the way towards even stronger economics relations between Germany and Israel. Now let's get started. I wish all of you a great gathering, fruitful of exchange and inspiring insights and ideas into the next step of developments in the photonic industry. Thank you.
So thank you, Esther, for your welcome address. And I believe Esther is here with us in the panelist discussion. And if there are questions, please use the chat function or the Q&A. And if there are no questions, at least I don't see any questions right now. Esther, if I can ask a question. So how can people out of Israel actually engage with you? What would be central topics? How can you help them in addressing, let's say, companies or industries in Germany?
So as I mentioned during the video, we are dealing with all kinds of sectors, and we encourage all of you, German and Israeli, to approach us through the email. Hi everybody. So I will write in the chat the email that you can approach us. Feel free to do so. We have managers here that divided sectorial, so you can approach them, and each manager will approach you and give you all the information needed, both about the Israeli ecosystem and about the German. Our services are free of charge, so I invite all of you to just write us an email and we'll be in touch.
Okay, maybe one last question from my side. Are there any events coming up? I know you are organizing events, you are fostering events. Are there any interesting events for this technology field?
Thank you so much. So basically we have lots of events also divided by sectors. So the upcoming events for our, we have one in PropTech next month, another one in the health and digital health, and the third one is going to be in the energy sector. And in the upcoming months, we're going to have events in the automotive sector, obviously, and lots of others. We are sending a newsletter to our audience, so you can see all the information over there. And again, whoever wants to sign up to this newsletter, I will be more than happy to do so.
Okay, thanks for now. And since Esther is in the discussion, if you have questions, please address her in the chat maybe or via email. Thank you very much, Esther. All right, and the next one on our program here today is Timon Rupp. I'm very happy that he can join us here this afternoon. Timon is founder and CEO of the Drivery here in Berlin. And Timon believes in the creative power of highly connected experts and entrepreneurs. And with the founding of the Drivery here in Berlin in 2018, he created a marketplace for mobility innovators. In a unique environment, the exchange of ideas and concepts between visionaries, investors, and politicians in the acceleration of innovation. Timon distinguished himself as an MDAX company executive, an entrepreneur, and a corporate venturing specialist with several successful foundations of startup companies. And today he will give us an insight on marketplaces, the flux compensator for innovation in mobility. So Timon, the floor is yours for your presentation.
Hello from the Drivery Berlin to all participants of the online symposium Photonics and Automotive. Thank you to the teams of Photonics Israel and OpTecBB for the kind invitation and perfect organization. Allow me to shortly introduce myself to you. My name is Timon Rupp. I studied microsystem engineering in Regensburg, and there was also my first contact to photonics. I worked for Siemens Semiconductors or Osram Semiconductors later, where I had the great pleasure 20 years ago to witness the first GaN-based, InGaN-based, blue, phosphor-converted white LEDs. From that point of time, I was attached to photonics, and basically the job for the next 18 years has been to promote that new technology into new markets, into new applications, especially into automotive, but later also into general lighting. It was a very exciting time. Sensors came up, lasers came up, and we illuminated the world in a very different way. Exciting times, and I tend to call that times, the good old days, because it was not always easy, but it has been comparably simple compared to what we see today. Nowadays, markets got more agile, products got more complex, the whole software part is coming in, and it's more tougher to get products done in a faster way. At the same time, the technology silos we have, on the other hand, are getting deeper and narrower continuously. So what happens? In the past, I just mentioned, we came from quite linear organized value chains. We had big corporations in the center. We had clear hierarchies, clear dependencies, and we got used to it to work in that way very effectively, especially in Europe. What is happening now? Innovation is not happening in a single lab, in a single company. Innovation is happening at hundreds and thousands of places at the same time in a very, very fast manner. But not full innovation, but only little pieces of it. So what we have to generate today to build true innovation is we have to act in ecosystems. And ecosystems require different structures. And for that reason, here in Berlin, with the Drivery, we generated a marketplace for innovation. So let me explain you what is the idea. So the idea is to bring all the bits and pieces within the ecosystem that are relevant for a specific vertical market, like mobility, under one roof, physically, but also onto one platform. In that way, we can harvest a tremendous amount of synergies within the ecosystem. But that's not where we end. We have optimized the infrastructure for the ecosystem to be utmost successful. So we ask ourselves, what are the next big things ahead coming up in mobility? And we adjusted the entire infrastructure to cope with it. An example is the GPU infrastructure we have here to deal with the AI applications. Everyone here is handling data in one or the other way. The data value chain is one of the new core features of mobility. So we adjusted to that. On top, we offer services to the ecosystem to be our members, our ecosystem members, utmost successful. This starts with financial services, prototyping services, whatever you need. We have more than 15 services that make each member and at the end the community and the ecosystem successful. And it's an acceleration effect. And this acceleration effect is not happening if people stay in their old structures. They need to go out, open up, find themselves in a new system and a new structure. You might wonder why I brought this wonderful DeLorean with me. The DeLorean for the driver community is more than just a car from a fancy movie. It's a symbol for the future of mobility and a technology platform where we will integrate the latest technology in mobility. Electrification is a big topic, autonomous driving is a big topic, new features for interior design. So it will be a really new version of the DeLorean, which we want to present on the EAA in Munich later this year. So if you have anything to contribute, a technology building block, an idea, might it be an ADAS, a LiDAR, a head-up display, maybe some projection technology. No matter if you have anything in mind that could fit into that beautiful car, let us know, get part of the project. We are looking forward to it. Looking ahead to the next year or upcoming years, photonics has a great future. And I understand it's a bit difficult probably for you to really imagine what the Drivery is all about. So I want to introduce you to see a short video about the Drivery and to pay us also a personal visit whenever you have time and feel like. So I'm looking forward to you and to create the future of mobility together with photonics. Thank you.
So Timon, thank you very much for your presentation. I don't see any questions in the chat or in the Q&A right now, so please allow me to ask a question. Of course, you mentioned the trends in mobility with respect to data, but besides data, what trends do you also see? And of course, you are at the forefront of trends, if I might say, at the Drivery in Berlin. With a lot of startups in your ecosystem. So what other trends do you see with respect to new business generation within the startups?
Hello, can you hear me?
We can hear but not see you. If you
my camera is not approved by the administrator, looks like. I tried to. Yeah, now can you hear me?
Go
perfect.
Ahead. Yes, please.
Hi there. Nice to meet you. Yeah, thank you, Frank, and the Photonics team for the introduction. Very nice to be here. Yeah, we see definitely a lot of, especially applications of photonics in the products of our members. So we have something like 120 startups in our community, and we see how radars, LiDARs, and the whole software layers behind it are applied in very exciting applications. So we see autonomous vehicles driving around, not on the road, but we have some cleaning vehicles. The data value chain is super important in combination with the sensor interfaces, the different sensor technologies. I see with kind of curiosity the battle between LiDAR, radar, camera, how everything is evolving, how everything is looking to get a place, and yeah, it's absolutely exciting. So that's why I really say by confidence that photonics has a great future also in mobility.
Okay, thank you. Since this audience today is quite international, and of course I do like the Drivery ecosystem, I have to admit, how can people engage with you guys? What would be do you have a technology radar that you are looking for, or does it have to be with something with mobility and you invite people to join? How can people contact you? Of course, via the internet, but what are you looking for?
Yeah, so we look for anything and anyone who can contribute something. And if it's an idea, a crazy one or a very boring one, I don't care, I don't judge, to the future of mobility. And it's sometimes it's out of the insurance area, sometimes it's from the mobility, maybe real estate area. So sometimes it's really interesting which areas contribute to mobility. We are very diverse, we are very international, we have people from all over the world, so we're highly diverse, typical Berlin. And also from Israel, we like to build stronger bridges to Israel going forward. We had some joint events in the Drivery. Before Corona, we had something 100 events during 1 year in the Drivery. So events, participate events, contact us, ping us. The doors are also open. If you happen to be in Berlin, just knock the doors. They're always open for you. So I'm happy to looking forward to meet you there.
Okay, maybe my last question, what about technology readiness levels? what kind of stage are these companies in when they are joining you?
I think technology is mostly ready. This is the good thing. So technology is mature, where there is a little bit of iteration going on. It's still on the business case. So how do I turn technology into a business case and into a revenue stream? So from bytes to the money. This is a bit the challenge. But there we try to support as well with our services and our ecosystem.
All right, Timon, thank you for your time this afternoon, and everybody in the audience, check out the website of the Drivery. It's a very cool place with respect to mobility.
Take care.
Thank you very much. All right, and the next one on the program here this afternoon is Anne-Sophie Reinelt. She's driven by the fascination of innovation and new business development. And Anne-Sophie Reinelt manages outside in and inside out activities for Hella. And before that, she built up and took the lead in managing the incubator at Trumpf, another very important and big German photonics company, of course, and from which activity numerous startups have emerged. She holds a degree in international business and in controlling, and in her master's degree, she focused on enterprise and technology management. So we are very much looking forward to your presentation this afternoon on enabling the future with new business models at Hella. So Anne-Sophie Reinelt, the floor is yours for your presentation.
Hi everyone. I'm happy to present Hella to you today and how we enable future business models together with startups. My name is Anne-Sophie Reinelt and I'm responsible for Hella Fast Forward in Berlin. I'd like to start with some facts and figures about Hella. We are a market-listed family-owned company with more than 125 locations in 35 countries in the world. We do have around 36,000 employees, thereof 8,000 in research and development. We do have an attractive business portfolio with the 3 segments: automotive, aftermarket, and special applications. When it comes to the segment automotive, we do have 2 business units, the 2 large ones, automotive lighting and automotive electronics. Since our foundation in 1899, Hella focused in particular on the expansion and for the development of a global production network by using tools like lean manufacturing, lean development, and design to cost. We established a product portfolio with high competitiveness in the context of global trends like autonomous driving, electrification, and digitalization. Taking a closer look at digitalization, because it has a high priority at Hella. We do have digital technologies for development and production. We do have state-of-the-art tools for global collaboration, and we do establish digital products. And we focused even more on this topic and emphasized this by introducing our CDO in April 2019 and by introducing also the digital strategy that focuses on 3 main areas of activities. The first one is enable future business models, where we take a closer look and the rest of the presentation on. And the second one is digitize our value chain, and the third one is innovate the way we work. How do we enable future business models? We enable future business models by supporting Hella's core business through a holistic innovation approach, by inside-in innovation, like ideation, by early identification of potential disruptive technologies and trends, like technology radar, and by scouting of startups, but not only startups, but also technologies that are still within research initiatives or institutes, and by investing in selected startups. And also we do have the Drivery, European largest mobility, co-working, innovation, community and marketplace. Hella has implemented a strong global network, starting in San Francisco, with Hella Venture San Francisco, who is investing into selected startups. Lippstadt in Berlin, with Lippstadt, where our management team is located and our CDO, and with Hella Fast Forward Berlin, which is focusing, or focusing on outside-in innovation, inside-in innovation, but especially on startup scouting for collaboration and co-innovation. And in Berlin, also the Drivery is located, our mobility innovation network. And last but not least, we do have Hella Fast Forward Shanghai, who's responsible for scouting and venture capital activities within Asia. And now we are looking for you. We are looking for startups in the automotive and mobility sector, as well as startups with smart factory and logistics solutions who are searching for strategic investors, cooperation and co-innovation partners, and for those who want to establish a presence in Berlin. So feel free and get in touch with me. Thank you for your attention.
So Anne-Sophie, thank you very much for your presentation and welcome here live in the video meeting. So hello. I don't see any questions right now in the chat or in the Q&A, so please use the opportunity to address your questions to Anne-Sophie Reinelt, and in the meantime, I'm asking questions again. So Anne-Sophie, maybe you can share with us what technologies are you looking for? You mentioned a technology radar, so what exactly are you looking for? We have seen a number of startups and established companies today, nice portfolio of topics. Was there something in it, of course, or what are you looking for?
Yeah, this morning I found a company presented its portfolio with, it's a startup we are working on with. I guess there are a lot of topics we are focusing on because our portfolio, it always needs to be related to our core business. So our core business does have a lot of, I would say focuses like lighting, electronics, and so on. But within the business units, there are also technology fields, and related to this technology fields, we are searching for startups. And then it depends on the business unit with whom we are working together, if they are looking more into the future. So it depends a bit on the scope the business division does have, if it's going to be an horizon 1, 2, or 3 topics. So so it depends if the technology needs to be a bit more mature or not.
And maybe a connected question. I also raised it with Timon in the last presentation. So what kind of technology readiness level are you looking for? With respect to startups, I understand they should be established, but what about your outside-in looking for technology process? Then of course it doesn't have to be a company yet. So can you share your view on that, please?
Yeah, that's right. When it comes to our technology scouting, our outside-in cooperation, co-innovation scouting, it does not need to be a company. It can also be a pure technology located perhaps just in a research institute or whatever. So it depends, or it's a new technology within another corporate we are cooperating then with. So it depends. It depends on the scouting. On the scouting scope we do have with we decided on to work on with the business division.
Okay, thank you. And there's a question from Costa, but I think it's more concerning the Drivery actually. So can a company join the Drivery, and if so, how? So I don't know, Anne-Sophie, if you want to answer, or if Timon wants to come on the stage again, please.
Is Timon still with us?
Timon, are you still there? No, I think we left the meeting.
Okay. But the shortest way is to contact Timon directly, but you also can contact me, and then I forwarded it to Timon. So it's a great place to stay. So join the Drivery. It's a great community and a good atmosphere over there.
And of course, we are all waiting for normal times to come again. What about this stage in time right now? Of course, everything is virtual. Can people virtually join the Drivery? Do you have any information on that?
They can virtually join the drivery, and I do know that Timon is working on a virtual room where we can meet then in the drivery all together. So yeah, it's going to be a great feature.
All right. Okay. Thank you, Anne-Sophie, for your presentation and also for your answers to my questions. And
thank you for having me.
Thank you very much.
Bye.
All right. And the next one on our program here today is Dr. Michael Marutzki from IAV here in Germany. In 2006, he received a PhD in physics at the Technical University in Braunschweig on optical spectroscopy. Between 2006 and 2008, he held a postdoc position at Max Planck Institute for Chemical Physics and Solids and Fraunhofer Center for Nanoelectronic Technologies in Dresden. And since 2008, he is a technical consultant for light and vision at IAV in Gifhorn. And here today, he will give a presentation on current challenges in exterior lighting and light assistance system. So Dr. Marutzki, the floor is yours.
My name is Michael Marutzki, and I am technical consultant for light and vision at IAV. Many thanks for this opportunity to talk about the current challenge. First, I will introduce my company IAV. Then I will talk about high resolution front light systems. And in the last part, I will speak about advanced.
One moment, please.
And I am technical consultant for this opportunity to talk about the current challenges in exterior lighting and lighting assistance systems. These are the contents of my talk. First, I will introduce my company IAV. Then I will talk about high resolution front light systems. And in the last part, I will speak about advanced driving assistance systems and sensor fusion. IAV is a development partner for the automotive industry. We are around 8,000 employees, and we are located all around over the world. Our headquarters is located in Berlin. Our largest development center is in Gifhorn, near Wolfsburg. And in order to be close to our customers, we have many offices and development centers all over Germany. This is our service portfolio. It ranges from e-mobility over vehicle development to smart industry. We have a lot of experiences in passenger cars and vans, but also in, for example, in energy or railways, marine and aviation. These are some of our customers. You see many car manufacturers and tier one suppliers of call. But now I would like to switch to the technical part. In order to give a motivation, I would like to talk about the so-called glare-free high beam systems. When you're driving at night and you have oncoming traffic, you have to turn down your light to the low beam, and so the oncoming driver isn't glared, but you have no illumination above the cutoff anymore. When you leave your high beam on, then the whole traffic space is very well illuminated, but you have maximum glare on the oncoming traffic, which is of course dangerous, and it is forbidden to move in such way, and so the glare-free high beam was invented. Here only the part where the oncoming car is detected is dimmed, and the rest of the traffic space above the cutoff is still illuminated, and so you have minimum glare and maximum illumination. The first of these systems came into serial 10 years ago, and they were mechanically, but we prefer digital systems in automotive industry. And so we came to matrix beam, where you can turn on and off LEDs separately. And the first of this system had around 25 pixels, and there was an evolution to more pixels, so you can dim out very exactly and sharply. And so in the last years, some high resolution LED modules were developed, which will come into the car, into serial within the next years. One of our contributions to this development was the design of a test bench for dynamic tests on such LED modules. We did this in cooperation with Infineon. Infineon has developed the LED module and integrated the micro AFS chip from Osram, and we designed this optomechanical setup in hardware and in software, and also developed the test specification. And as you see in the photograph, this LED module allows high resolution light functions. Here we see a scheme of this test bench. The LED module is mounted at A, and then we have 3 optical paths. In C, we have a photodiode for integrated measurements of the light flux, and in B, an industrial camera for measurements in spatial resolution, and in D, we have a path to a measurement screen in order to make photometric measurements with a luminance camera, or in order to observe with your own eyes. Not only the component is to be tested, but also the whole system, which consists of a sensor, normally a camera, and some intelligence located in the control units, and then the actor, the high resolution pixel light headlamp. And our solution is presented in the video on the next slide. On the left, you see a measurement screen, and on this measurement screen, the dynamic light distributions of the headlamp. In the background, there is a LED screen where we simulate the other traffic participants, and the LED screen stimulates the camera, which is located near the mirror. We use a luminance camera for quantitative photometric measurements. This is how it looks like. And you can use this quantitative luminance measurements as an input for light simulations in order to make a deeper analysis of your light distributions and the system. there are still some challenges to solve. First, we have a parallax between the camera sensor, which is mostly located near the mirror, and the headlamp. And so you have to make a coordinate transformation in order to dim out the right part of the traffic space. The object detection is a challenge. And we have to answer the question where the intelligence of the system is located and how are the data transported from the sensor to the actor. And when we have pixelite systems, this is, of course, masses of data. Now I would like to give some solutions. We are talking about automatic driving in level 4 or 5. This means highly automated or autonomous driving. And here we require a lot of sensors in order to sense all of our traffic space around us. And maybe these are 50 or more sensors. And here we see that the lamps of the car, which are located at the edges of your car, are strategic positions for perceptions for most situations. And so we made a project with ZKW, the project Dragonfly, and here we integrated sensors directly in the headlamp. On this slide, we see some of our experiences in autonomous driving. One is the Renault Symbioz demo car, and another is our HEAT project. This is a bus for public transportation, and it is moving automatically in Hamburg Hafen City. And so we have sensors all around of our car, and then we are able to detect such complicated situation like it is shown on this slide. And one use case is a lane change assistant. Another use case are the advanced light functions, and so I come back to the first part of my talk again. And so the camera, the sensor, the ECU as intelligence, and the actor, the pixelite module, is located in one housing, and you solve a lot of problems. You reduce the complexity of your system, and also you have the same optical axis for the camera and the pixelite module, and so the world is much better now. Now my time is over and I have to summarize. I showed that high-resolution headlamp modules are new technologies which give the opportunity for new dynamic light functions. We developed test setups for dynamic component and system testing. I showed some challenges and give an example how these challenges can be solved. And I showed a concept for sensor fusion for highly automated driving. Many thanks.
Thank you, Dr. Marutsky. Unfortunately, I have to announce that he is not here with us this afternoon in the panel. However, there is a question in the chat, and I will forward the question to Dr. Marutsky. If you are interested in contacting to IAV, which is a very interesting and also a very important engineering company in the automotive industry, please send me an email, and I am happy to e-connect you to Dr. Marutsky or to other people within IAV. And with that, we are continuing with the program. I would like to announce Rolando Ferrini. He is head of CSEM, micro, nano optics, and managing director of Fabulous. He joined CSEM in Muterns in Switzerland in 2011. And since 2020, he coordinates the Horizon 2020 project Fabulous, and he acts as a managing director of the corresponding pilot line for the manufacturing of freeform micro-optical components. In 1999, he obtained a PhD degree in physics from the University Pavia in Italy, with a thesis on optical properties of 3-5 semiconductor materials for electronics and optoelectronics. And from 2000 to 2004, he worked as research associate at the Swiss Federal Institute of Technology, EPFL in Lausanne in Switzerland, where he studied the optical properties of semiconductor-based photonic crystal devices. And from 2004 to 2011, as a senior research associate at EPFL, he was in charge of the activities on organic devices for optics, photonics, and lighting. And here this afternoon, he will give a presentation on new era for micro optics manufacturing, European pilot line for freeform micro optics. So Rolando, the floor is yours.
Hello, my name is Rolando Ferrini. I work for CSM in Switzerland, where I'm responsible of the activities in micro nano optics. First of all, I would like to thank the organizers of the event for having given me the possibility of telling you in the next 10 minutes about the manufacturing of freeform micro optics, which is the final frontier of micro optics. First of all, just let me introduce my company that some of you may not know. So CSM is a Swiss private company, non-for-profit, that deals with technology transfer. So we develop technologies and technology platforms that then we transfer to industry. The activities I'm responsible for are in the field of micro nano optics. How do we do micro nano optics at CSM? We do it by UV imprints. We start always from designing and simulating the structures that we want to fabricate. How we fabricate the structures, we produce what we call an original. It contains the original structures that we want to fabricate. It can be, for example, in glass, it can be in quartz. Out of this, we produce a nickel shim, which is the tool that we'll be using for production. And how we produce the structures, we put a UV imprintable lacquer on a substrate. Then we come with the tool, we press, and we shine UV light. When the light is absorbed, the photopolymer is cured and is hardened. Then we demold and the structure is transferred on the substrate. We can do this for prototyping on 6-inch wafers, but we're also trying to push forward our capabilities and bridging the gap which is between prototyping and volume production in two ways. On the one hand, going for larger surfaces. So we are installing these days new machines from a company called Photonics, which is a roll-to-plate machine that will allow us to go broader than 6 inches. And also we are pushing forward in the Death Valley between prototyping and production, which is the piloting phase. When it comes to volume production, we transfer the production to our partners, our industrial partners for production. And we are nowadays pushing this from, after several years of experience in nano and micro optics, we are pushing in the field of freeform micro optics, where we are leading a European project that is meant to set up a pilot line for the manufacturing of freeform micro optics, Fabulous. So first of all, before telling you about Fabulous, how Fabulous is linked to automotive lighting, I would like to tell you about freeform micro optics. For sure, you know freeform optics, which is today a product reality in automotive lighting. These are optical components where you remove any symmetry constraints on the surfaces. What you can do, you can add new functionalities, you can simplify your optical systems, you can easily integrate these new optical systems, for example, in lighting systems containing LEDs. You also know micro optics. These are, in general, for example, microlens arrays. that allows you to miniaturize your optical system, to add new functionalities, go for low weight and large area optical elements, which can be flexible or conformable, and low cost at mass production. Now you put together the two domains and you have freeform micro-optics. So micro-optical elements where you lose symmetry restrictions, as you can see here on this slide on the bottom right. This is not technology push. There is a real market interest. As you can see here from on left bottom, you have a graph showing how quick the patents and the publications in the field of freeform micro-optics were growing in the last 2-3 years. So there is really a request, a demand from market, from companies to integrate freeform micro-optical components into their products. One of the hottest markets that we have identified is automotive lighting. In automotive lighting today, micro-optics is already a reality, it's a product reality. You see here, for example, double-sided micro-lens arrays produced by a company in Switzerland, which is also part of the fabulous micro-optics. These elements put in front of LEDs integrated into, for example, the side mirrors, produce this marvelous light carpet that you can see here around the car, which is more an aesthetic factor. But this is actually booming as field. And today, more and more companies are looking into freeform micro-optical components also to be integrated into, for example, other more functional elements in the car, like headlamps. This is, for example, the objective of Headlamp, that you for sure knows. That is one of the use case partners in Fabulous. I will tell you in a few minutes what a use case partner is. But the objective of Headlamp is to look into freeform micro-optics for automotive, especially automotive headlamps, with the idea to manufacture or enabling the manufacturing of these innovative components that are meant to reduce, for example, or simplify the optical systems that are integrated into the headlamps and to improve the efficiency of the optical systems. Here you see the advantages that have been identified by Headlamp for freeform micro-optics applied to headlamps. In general, it goes a lot with the simplification of the optical systems, combining different optical functionalities in one single element. You can also combine several optical surfaces in one single surface. And in the end, your complex optical system is simplified, is easier to be integrated, which reduces the cost of production, but also allows to produce or to have new, more efficient lighting products. The idea of Headlamp in Fabulous is to explore freeform micro-optics or the manufacturability of freeform micro-optics for two functions in headlamps, low and high beam. The idea is to have headlights with uniform appearance in on-off state, with high beam and asymmetric low beam, with low stray light, homogeneous light distribution, which is very compact a system and low weight. That's the objective. And actually, before getting there, you have to manufacture these optical components. And it's where the problems, let's say, in general starts, because fabricating freeform micro-optical components is not easy. It requires the access to very advanced technologies, and the value chain to produce these components is broader than a standard value chain for micro-optics. So what's Fabulous and how Fabulous can help and to put on the market new products with new freeform micro-optical components? Fabulous is one-stop shop for the manufacturing of freeform micro-optics, offering accelerating innovation and production cycles, manufacturing services going from prototyping to piloting to large volume production. Fabulous was born at the beginning of 2020 as a European project that got 15 million funding from Brussels in order to set up this distributed pilot line. What is a distributed pilot line? Distributed pilot line is a pilot line where each element on the value chain exists in a specific place, but not on the same spot. So there will be several partners you can see here distributed in Europe. Each of them masters one element on the value chain. And putting together these partners, we'll have a distributed pilot line. There are another set of partners that you see here, which we call them the use cases. These are not part of the pilot line, but they're helping the technology providers to set up the pilot line. How? Just testing their production processes against product needs in order to be sure that this is not technology push, for this market pool, so that what we are setting up as production line can be immediately functional to the selected markets, among which there is, for example, automotive lighting, where we have Hella as partner, but we have also general lighting with Suntobo, transportation lighting with Eisenbacher, with luxury with Swarovski, and AR/VR with Microlight and Limba. So what we are building is this value chain that you can see on this slide. So we'll cover the entire value chain for the production of freeform optical components, going from modeling to the origination, which is one of the bottlenecks, where we have access to a lot of different technologies in order to be able to originate these small micro-optical elements with no symmetry constraint. Tooling, because most of the time you can originate these elements on very tiny surfaces, so then you have to extend the structured surface in order to have your tool addressing the size that is required by your product. This we do with additional processes like, for example, separating. You need to tweak your material for certain applications, for example, high-low refractive index materials. You need to control the quality of your imprint process. And then you have to go into production. And we go into production with 3 pillars. We go at wafer scale on wafers, up to 8 inches wafers with SUS micro-optics. We go to roll to plate with more photonics. So the structure is on a roll that is depositing the structure in the surface of a plate. Here we can go up to A3, for example, even broader, up to 1 square meter. And when you want to go to really square kilometers, you go to roll, where we have a partner in Finland called Nanocomp. And then we integrate these elements into the products. How we are building the pilot line? We are building the pilot line in 2 different phases. The first 2 years are devoted to the pilot line setup. So we are really linking all the elements of the value chain in order to be sure that we'll have a smooth process workflow from modeling up to production and testing. And this we're doing, as said, with the help of the use cases that tell us what is compatible or not with their production or product requirements. In the second phase of the project, year 3 and 4, so starting from the end of this year, beginning of next year, we will open calls for what we call pilot cases. Pilot cases are companies that today are already willing to have prototyping or piloting of freeform micro-optical components for their products. They will apply for prototyping or piloting runs on the pilot line. If they are chosen, the advantage is that part of their work will be funded by the pilot line itself. And where is the win-win situation is that we will actually work in close collaboration with these pilot cases, and we'll ask them to give us feedbacks on our production processes, but even more on our business model, because the pilot line is meant to survive after the 4th year of the project and remain as a self-sustainable pilot line serving the European industry requiring freeform micro-optical components. Why we're doing this? Why this effort from Brussels to fund the build-up of this pilot line? The reason is simple. If today you're a company, especially small and medium companies that would like to implement freeform micro-optical components in your products, you have to build your own value chain. You have to go through each of these steps and find the right partner, and actually find partners or technologies that can match each other. This can be very cumbersome and time-consuming. This has 2 side effects. On one hand, prevents certain companies from having access to this technology. On the other hand, prevents the technology providers from increasing their business. So the solution we propose is to have one entry point with an optimized value chain behind that has been already optimized for the real production of freeform micro-optical components. And for which market we do this, you see here the list of markets that we have identified as the hottest markets requiring freeform micro-optical components, and it covers almost every market in photonics. The hottest markets are automotive lighting, solid-state lighting, AR, VR, and consumer electronics. And with this, I would like to thank you for your attention, to remind you that micro-optics is fabulous, and to leave you my contact details if you are interested in knowing more about fabulous and freeform micro-optics. Thank you very much, and I will get your questions.
Okay, thank you very much for the presentation. And Rolando Ferrini is here with us this afternoon. Hello. And while I'm encouraging everybody to state their questions in the Q&A or chat, I would like to ask a technical question. What's the smallest features or structures that you can actually produce or generate within the Fabulous ecosystem?
Let's say we are targeting micro-optics, which means the feature sizes go from a few microns up to hundreds of microns, so always below 1 millimeter, above the hundreds of nanometers. With a small disclaimer, the same technology is also currently used for nano-optics. So there's not really limitations in the feature sizes.
Okay, since there's no questions so far, I do have another question concerning the, let's say, the technology development process, or how people can approach CSEM or Fabulous. If I would like to develop some micro-optical components with you, who would I actually have a contract with, a contract?
So there's no easy question answer at the moment, because we are also currently discussing about the business model and how will we run the services. But most probably the model will be the following: the contact point will be the front office, so the companies will contact Fabulous front office. The request will be analyzed by our technical team. There will be a decision on which are the members of the pilot line that should jump on board in the technical discussions. And once the technical discussions are run, there will be an offer. The offer will be issued, and so the contract will be legally with one of the members of the pilot line, one of the companies producing the components that will be the prime contractor. But the offer will contain inside the work for the other subcontractors that will be necessary along the value chain to fulfill the final, let's say, contract. So there will be one entry point and one contracting partner.
Okay, thank you. And there's actually a question: what kind of form errors are possible, and what kind of surface deviations, like peak to valley errors?
There's no easy answer. It depends on the shapes. If we are, let's say, going towards shapes that are more roundish, or shapes that are pyramidal, it's depending on the feature size. It's really too vast to answer. We can answer when we have specific geometries, and then we can also run some simulations that we call design for manufacturing, which means that we can simulate already what would be the shape that we can manufacture, what would be the impact of any type of deviation in shape and in surface quality on the optical properties.
Okay, thank you. And maybe last question for now. Do you also manufacture metastructures?
That's a very good question. I would have another question. Please define metastructures. Yes, metasurfaces, we do it. Can be done with UV imprint technologies. We have some contacts as CSEM. Metasurfaces are usually in the nano domain, so they are a bit aside from Fabulous, but this is possible to be produced by imprint too.
Okay, and maybe now the really final question from Pietro. Divergence is lambda over D. The narrower the headlamp, the most difficult to control intensity distribution. In headlamp design, what future do you envision?
Yeah, there is a lot of efforts that are deployed at the moment by also companies on board like Headlamp to understand what is the potential of freeform micro-optics. What I can disclose, what I can say, is that the advantage of using these freeform surfaces is that you can really almost direct ray by ray where you need to put them, and so it's really the control of the optical, let's say, of the beam shaping, which is done at the level of the single ray. So we see the potential. Where is the let's say the limit? It still needs to be explored.
Okay, thank you, Rolando, for your presentation and answering the questions. I might ask you to put down your email address in the chat. So if there are further questions, I'm sure there are in the audience, so that you can answer the questions bilaterally. So thank you for your talk and your time this afternoon.
Thank you very much. Bye-bye.
And with that, I would like to introduce and welcome Gerald Uhlenberg on the virtual floor. He is the Managing Director of TechQ Engineering, a specialty LED and laser modules company with locations in Berlin in Germany and in Taiwan. And after his education as a physicist, he has been working in the lighting industry for more than 20 years. And here this afternoon, he will give us some insights on projection and laser technology for digital lighting. So Gerald Uhlenberg, the floor is yours.
Good morning, good afternoon. My name is Gerald Uhlenberg from TechQ Technology. Within the next few minutes, I would like to give you an overview about our company, TechQ Technology, and an insight into one of our key focus areas, digital projection technologies used in automotive applications. This is a snapshot, a summary of our company, TechQ Technology. We are serving the automotive lighting industry, but also special lighting applications such as medical fiber lights or effect concert lights. The service that we are providing to our customers is on one side engineering services like feasibility projects, concept studies, but more often we do the full product development and also the later manufacturing and supply of certain series products such as customized light modules, light engines, projector units, and so on. The key focus area or know-how of our company is twofold. On one side, projection technology. This is what I will report about today. And second, about laser modules. And we do have locations in Taiwan, in Tainan, in the southwest of Taiwan, and also in Berlin, Germany. I will talk about DLP projection today, meaning very high resolution projectors using Texas Instruments DMDs, micromirror devices, as the digital imager. And these kind of projectors are now more and more often also finding their way into automotive applications. Some of them are shown here. Already in the market are DLP modules shown here on the top for front lights, for headlights in cars. So that you can do very fancy or sophisticated lighting distributions as the front headlight. I will show you two examples of two other applications or use cases. One of them is ground projector, in which you are using very small size DLP projectors to project images, pattern, dynamic video sequences around the car. That is an exterior automotive lighting application, but DLP projectors are now also being targeted for use in interior applications such as transparent displays for side windows, or for sure picture generating units for head-up display applications in which DLP projectors are also used. For all of these applications we are designing and manufacturing modules, and two of these examples I will show you on the next pages. Here's an example of a DLP projector used for side mirror installation. For sure, these projectors need to be very small size, compact to fit into an automotive side mirror. All the components have to be automotive grade, including the DMD itself. And also the electronics configuration is optimized for small size and low cost, meaning that we are using an FPGA configuration to control the DMD, and using pre-installed video sequences that the user can select. Now, these kind of projectors reach up to about 100 lumens, so they're not only used for logo projection, but could also be used for safety functions like projecting an indicator onto the street, or for welcome scenarios and light carpets. Next, one further example of DLP projectors being used in automotive application is a so-called in-plane head-up display. We are here working very closely with Series Holographics by using their holographic foils as the combiner element for the head-up display. Opposite to other head-up display, actually this is so-called in-plane technology, meaning that the image or the display appears in the plane of the windshield. But the technology allows extremely small package volumes with a very large field of view. And additionally, you can also use off-axis projection, meaning that you are very versatile in positioning the projector compared to the windshield requirements. And I'm showing this little video here with permission of Series Holographics. Okay, thanks very much for your attention, and I'm looking forward for any questions or further discussions offline later. Thanks very much.
Thank you, Mr. Uhlenberg. And while again, everybody I'm encouraging everybody to use the chat for raising questions. We have a few more minutes for Q&A. So, Mr. Uhlenberg, I have a question. Where do you see the main technical bottlenecks? Is it the optics, the integration, or the system integration, or is it actually the DLPs, the projectors? Where's the main work that needs to be done to make them smaller, to make them less expensive?
Yes, for automotive applications, sure, the cost target is very aggressive. So reducing the cost for these small size projectors is I think the key target here, because once you are talking about dynamic, for instance, dynamic projection around the car, you would often like to have not only one projector but many projectors around the car to have a surround projection. And then cost is one very, very important factor for automotive. And second, I think on the projection side, it's often very difficult for projection requirements because you often would like to install the projector at a very low height in the rocker of the car, for instance. And that imposes quite some difficulties on the projection conditions, so to say.
Okay, and maybe with respect to a wish list, everybody has a wish list. If you are thinking about the further development of your projectors, the technologies, what is the kind of technologies that I'm looking for in other ecosystems, maybe in Israel, here in Europe, somewhere abroad? What are you looking for? What kind of collaboration?
I mean, one important side for let's say interior applications, especially if you would like to project onto the windows of cars, is the film technology or the transparent window technology that you would like to use there. So questions of how to laminate these foils, there are different technologies, how to laminate them into the car windows on low cost and so on. That's, I think, also still a key question that is currently being developed and looked into.
Okay, thank you. There are no questions in the chat, so I would like also to ask you to leave your email address maybe in the chat, so everybody who still has questions can contact you directly. Thank you very much for your presentation and for being around this afternoon. And the next one on the program, unfortunately, or the time is passing fast. I would like to introduce Khaled Layouni from Corning in France. He is a technology manager for Corning Automotive Glass Solutions, Autograde, Corning Gorilla Glass, and Corning Coldform Technology Innovation Teams. And his role, he leads reliability programming for the entire business. And Dr. Layouni has held a number of development roles at Corning Incorporated since joining the company in 2009. And he holds a PhD in fracture mechanics from the École des Mines in Paris. And here this afternoon, he will give a presentation on Corning Incorporated Autograde, Corning Gorilla Glass, and Corning Coldform Technology, innovative solutions for automotive applications. And I'm very much looking forward to this presentation on other materials that can be used, of course, within the car and maybe also outside of the car. So, Mr. Layouni, the floor is yours.
Hi, my name is Khaled Layouni. I'm technology manager working for Corning Automotive Glass Solutions business. Today, I'll be talking about two innovative solutions that we have created for automotive applications. The first one is auto-grade Corning Gorilla Glass, and the second one is Corning cold form technology. Many of you may know Corning. We've been around for 170 years, paving the way for groundbreaking innovations that have transformed the way we live. We are heavy players in the display industry with our glass innovations, and you may have recognized Corning Gorilla Glass, which has been featured for more than 6 billion consumer electronics devices worldwide. You use your phone every day, and it's likely it has Gorilla Glass on it. If you're like me, you also interact with your vehicle every day on your daily commute to work, and often for prolonged periods during weekend getaways. Today, innovation inside automobiles is accelerating at a faster speed than ever before. The reason? Something industry experts call CASE, which stands for Cars that are Connected, Autonomous, Shared, and Electrified. Consumers are not buying cars based solely on horsepower or the exterior look anymore. They are buying based on the design of the car interior. They want the experience, interaction, and connectivity they are used to from their smartphones inside their vehicles. We were pulled into this opportunity rather quickly because we helped create the ecosystem. Through our display glass and glass for mobile consumer electronics, our expertise makes us a key player in this space. And thanks to our reputation as a company that can deliver solutions and work with customers to deliver on their design needs, automakers and customers are pulling for our glass as an innovation that can deliver on these four trends. With the glass as enabling material, this means the auto industry is shifting toward more glass with more form and more function, which is great news for us at Corning. We're moving from the type of designs prevalent on the left to the designs that are far more aesthetically interesting, like what you see on the right-hand side of the slide. Our expertise in specialty glass and optical physics has made us uniquely positioned to bridge the gap between consumers' desired user experience inside the car and the industry's requirement for in-vehicle materials. We invented auto-grade Corning Gorilla Glass, a product we announced in 2019, which is the cousin of the glass on your smartphone. But there is one catch. It has been specifically formulated and optimized for automotive interior applications. Let me explain. Our cover glass expertise in automotive systems comes from our experience in mobile consumer electronics, with one key difference. You can drop your phone, but you're not going to be dropping the display in your car. My team and I underwent extensive testing in our labs to fully understand the use case and its reliability requirements. Imagine a car accident where a passenger propels forward upon impact and risk hitting their heads on the dashboard. That's what the head-form impact test simulates. During hit, surfaces in the dash should not break in the way that could harm the occupants. These are demanding standards, and they are held worldwide. Like our other technical glass for other use cases, our auto-grade Gorilla Glass has something we call retained strength. But this version of retained strength has been tuned to help our glass survive hit. Just watch this video. Our glass absorbs the force of the impact in a sense which helps to prevent the breakage of the cover glass. It looks like the display was not so lucky. Now let me show you what's happening to the glass during an impact event such as this. The glass is under bending and puts the flaws under tension. Auto glass was designed to prevent flaws propagation under such event and hence survive hit. What's important to remember about our extensive knowledge of hit is that it applies to the system as a whole. Customers that abide by our carefully calculated design guidelines can expect a superior cover glass product that fits the automotive use case. My expertise here is in the science of glass breakage. And what we've learned over the years is that the glass normally breaks because flaws have been introduced during the manufacturing process, handling, conveyor belts, traveling through the supply chain. The fraction mechanics can help predicting the glass strength. In fact, when a load is applied, the cover glass can resist until the stress intensity factor reaches a critical value called fracture toughness. By manipulating the equations, you can see in the left-hand side box that you can predict the maximum load before glass breakage. It depends on its composition and supply chain flaws. Cover glass breaks during the head form impact because stress has been applied to its existing flaws, which get pulled on and essentially break, causing the glass to crack. Flaws are for the most part unavoidable, and our auto-grade Corning Gorilla Glass formula, from the glass composition to the chemical strengthening, is designed to withstand the stress during hit. An exciting challenge for Corning that really pushed the boundaries of what's possible with the glass is when you introduce shaped modules to these vehicles. Back to my original point on case, consumers are beginning to base their vehicle buying decisions on the interior design of the car. This means many automakers are working on any type of design differentiation that might attract these choosy buyers. There is a way to achieve these new and innovative designs with the glass using Corning cold form technology, which we showcased just last year with GAC at the 2020 Consumer Electronics Show in Las Vegas. Our technology is different because it starts as a flat piece that can bend into its final shape versus the traditional way of making shaped glass parts, which requires expensive hot molding and tuning. By traveling through the manufacturing process in its flat state, our finished glass part has more uniform optical coatings and is produced at higher yields, which dramatically impacts the final price for our supply chain partners and thus automakers. We've compared our technology with traditional hot forming, and the value is clear. We can achieve superior economics for our customers and enable improved optics performance, all enabling automotive interior system to pass hit without glass breakage. Also, our 3D cold form technology has successfully passed stringent reliability testing according to many OEM standards. We've combined our auto-grade Corning Gorilla Glass with this innovative bending technology to help enable a new wave of interior designs with clear benefits. We designed our glass and developed a shaping technology that enables us to ship glass in a flat state for bending into its final shape once it reaches its destination. In addition, we share our glass guidance with customers to help them produce high-quality automotive interior systems that pass hit. The auto industry has reached an innovation inflection point, and we're standing at the ready with new manufacturing capabilities in Hefei, China, and strategic collaborations across the industry. We see an exciting future for glass in the auto industry as it solves case trends and steep advancements at a pace the industry has never seen. Our 170 years as a company make us old and experienced, while our industry knowledge and business portfolio makes us innovative and agile. We're excited to see how and where the auto industry moves and are centrally prepared for the ride. Thank you for your attention.
Mr. Layuni, thank you very much for your presentation, and thanks for being here with us this afternoon. Everybody else in the audience, please use your chance to address your questions using the chat or the Q&A. And in the meantime, I do have a question again. What are the sizes of glass structures that you foresee within the car? Of course, we have seen this big display glass, but are you also supplying, let's say, smaller displays or even larger ones? What do you see in the future?
So we are covering all the sizes that are possible in the market. Most of the sizes probably are less than 800 millimeter, but we are capable of making pillar to pillar, which is 1.5 meter apart. You are mentioning the big display size that we have seen recently, and actually Daimler Mercedes-Benz choose Corning Gorilla Glass for automotive interiors for its all-new NBUX Hyperscreen, which is the largest monolithic glass part to be featured on the market. That was Corning Gorilla Glass, actually.
And in this conference today, we have seen a lot of sensor companies, photonics-based sensor companies for the interior and also for the exterior of the car. Why should they contact you early on, maybe in their development process, to include your latest technology in glass?
Yeah, I think because the use of cold forming technology, it enables taking a full advantage of the display, because the decoration and the coating that is put on the glass is put on the flat state. So the optical performance is very good, is better than the incumbent technology. So which means that when combining the higher optical performance with the display performance, the finer 3D shaped display performance is way beyond the incumbent technology.
Okay, thank you. And there's one question from the audience, from Martin. What are the forms which are achievable by the new cold forming? Is it correct to assume one-dimensional bend only?
Yeah, so generally, yes. Generally, we have most of the shapes deal with one axis bending. However, with some extent, we can do some compound shaping, but it is related to the Gaussian number. But we can do some compound shapes, but it's limited.
Okay, thank you very much. And if you could also quickly put down your email address into the chat, so if there are further questions, people can directly contact you. Thank you very much for your presentation and for being around for the short question and answer session. But of course, this is just an introduction, like all the other presentations. And with that, we are actually through for our conference here today and this afternoon. I would quickly like to thank again the organizers, Nofar at AEAI in Israel, and also Anastasia here at OpTecBB, and Shlomo, I don't know if you could turn on your camera real quick, and would like to come on the stage again. Thanks also to you, and if you want to address the audience for a few more words, please go ahead. Before you do that, I believe we will share the presentations, or at least the recording will be available afterwards. And I would also like to remind you to check out the websites either at OpTecBB or OpTecNet, or the information given by Photonics Israel, their newsletters and our newsletters. We have many more ideas for very nice events coming up. And with that, I would like to thank you all, also the speakers, of course, for giving such nice presentations here today. And stay safe, and hopefully see you soon again in real life. Thank you very much, and bye-bye. So Shlomo, would you like to address everybody?
Yes, it was a very good conference. I would like to thank the OpTecBB that organized with us this conference, Frank and Anastasia, of course Nofar, and Yaniv that was on the computer things. We would like to see you all in our conference in June. It's Photonic Days Israel. And of course, you may be welcome on our weekly webinars. It is professional webinars and many topics of photonics. So you may listen to very interesting topics. Thank you again, and have a good night.